Hi folks, I'm Tom Sabo. I'll try to strike a balance between like talking loud so folks can hear me and not talking so loud so the folks of you on the headphones don't get your ears blown away. In the spirit of how technology is just evolving so quickly all the time, I think like 15 minutes ago I decided to evolve this presentation. So while we're still going to talk a lot about text analytics for the public sector and generative AI, we're also going to evolve this a little bit to, oh, what happened? Oh my gosh, the whole presentation changed. We're going to evolve this to like be a bit more in line with those of you who attended opening session today. Okay, cool. So did you hear Brian Harris like talk a bit about agentic AI and that kind of message? So last year I did a lot of focus around taking the best of what SaaS Viya had to offer, and I've been supporting public sector as a solutions architect at SaaS for 14 years. And I've been taking the best of what essentially SaaS has to offer, SaaS Viya in particular, and I've been doing text analytics, and seeing how essentially we could combine that with all of the capabilities coming out in large language models. So I could give you recommendations on, here's how you can apply this to some of your work. Here's some of the use cases that you can apply. And this is all part of like the SaaS AI message. So you've got those first two pillars, which are largely around co-pilots. Essentially, hey, I'm working with visual analytics. How can I make that work better? Great. The fourth one is synthetic data, but I'm focusing more on this third use case here where you can use SaaS Viya to essentially build applications that can make your life and your job easier. And when we put this in the context of agentic AI now, we're talking about taking those use cases and doing it in a context where, let's say these are the most difficult parts of my processes. How can I automate some of that? How can I stand up capabilities to do some of those most difficult tasks and make them easier in the context of my workflows? So here, I'm going to talk about this in the context of intelligent decisioning, which Brian has talked about. I'm going to put this in the context of here's how you can use text analytics at SaaS to make that whole process better, and that fits with the third one, and then glue it all together essentially with like studio steps. So like as we go through, I think like the thing that maybe you might benefit the most from is thinking in the context of, hey, what are my different use cases? What are the parts of my flows? What are the parts of my work stream that would benefit the most from some level of automation? And when we talk about automation, we don't necessarily mean like human out of the loop. This could be some level of human oversight. And oftentimes it's a lot of human oversight, especially with public sector use cases where oftentimes lives are at stake. So I talk a lot about text analytics, and SaaS offers and has been offering for years what you see over on the right, this linguistic rules, where essentially you can use people, like I can sit down with a lawyer, for instance, or I can teach someone to sit down with a lawyer, whose job it is to look over like thousands of housing agreements and identify the civil rights violations in them. And I can learn the kind of patterns that they're looking for, and we can encode that in a matter of hours, where it can then go in and present to her, hey, instead of you having to look at every document from scratch, let's just go look over these parts of these different sections, because this is where we most suspect that there are these civil rights violations that you're looking for. So combine that all with the best and brightest around like language models, large language models and machine learning, and I'm mostly dealing with LLMs these days, and we have an approach that's really this composite AI approach where maybe instead of dumping all of your data on a large language model and asking questions there, you use these text analytics processes that SaaS has been doing for years, which are much less expensive to find that relevant subset of data that actually will answer your problem. Give that to the large language model, and now you can get much more focused answers for less costs that will, someone said they didn't like the word hallucinate, but they'll give you better answers. I like that too. And also provide you a traceability component. And I'll show you a little bit of that around public sector. This is the idea of agenticizing a flow. I really like how Brian Harris characterized this, where you're essentially taking flows or parts of the logic, parts of your work stream, putting into an agent. And then like at the top here, when it says banking website, I mean, this could be like police narrative events that are flowing into a system. And your agent might be looking at each one and categorizing them as, oh, this looks like it has a component of human trafficking to it. I'm going to route it to this different workflow. So like this idea of agents supporting agents is something that we've been doing for a while. And I think there's a lot of discussion out there around what is agentic workflows. And I really like how Brian Harris characterized this, particularly because now we're talking about benefiting from all of the different orchestration and governance capabilities that Vaya has to offer. And then you can see how this can fit into essentially now the lineage that Brian has been talking about earlier too, where, hey, this is an intelligent decision or a capability that can encapsulate a process, and it leverages models, can oversee those models, can handle the data management, and all this comes together into something now that is more ready for production than maybe what we've glued together between large language models, and more code. All that is to set up for this part where here are the different places where I've applied these. And this is also my favorite Choose Your Own Adventure book from the 1980s. There was 5 good endings and then 17 terrible endings. And it was very amusing to stumble through that. Kind of like we've been stumbling through all of this new technology that's coming forward. So my job is to help you choose the right endings. They're all good endings for these. To get a better sense of, okay, well, you talked to me about generative AI, you talked to me about AI and agentic data. Let's look at some of these. So I'll be at the public sector booth today, over there, today and tomorrow. You can ask me about any of these in detail. For now, I'm gonna go up here and choose one unless, let's see, maybe I'll offer 2 to you. Who wants to see more around okay, did anybody come through New Jersey, New York? LaGuardia, Newark by any chance on the way here? Any airport goers? Not seeing any. Oh, you got one over here? One over there? Okay, awesome, fantastic. How was you? I hope you had a good experience. You didn't have a good experience. Okay, let's talk about that. So I think this is one that's relatable to everybody who's had maybe the not best of experiences at your local airport as you're going through it. I mean, we all threw in an airport today, or yesterday, or the day before. And I was talking to one of my colleagues who next year is going to do the direct flight rather than trying to save the company $100 by being 6 hours late because an airplane got delayed. So the idea here is, and this is largely based on customer feedback. So a lot of organizations can benefit from this, whether they're public sector or whether they're commercial or not. So essentially we were working with a port authority who had public feedback, and they wanted to just better understand customer feedback around 3 different airports. And in particular, they wanted to understand feedback related to staff attitudes and the food and beverage service, and essentially people finding their way around airports. This is one of those cases where, in this case, we received, I believe, 8,000 comments, and they're publicly facing comments, so I can talk to you about them today at a pretty high level. There's no PII in here either. So the idea is, how can we take those 8,000 comments and essentially stand up something that anybody can use, anybody can get feedback on and make some sense of, and actually get some actionable information out of this too. Okay, don't just show me a dashboard like this, but also show me a bit of an action plan as a part of it. This is where, instead of taking those 8,000 comments and dumping them on a large language model and saying, hey, just tell me what people think about, signage, or tell me what people think around, the food at the organization. I ran a text analytics model using SAS Visual Text Analytics beforehand to just grab those subsets of data that deal very specifically with customer attitudes, and then deal very specifically with signage, and then also food and beverage. And those turn out to be a much smaller subset of the comments. And this scales too. I could be looking at millions of comments and then just grab the 1% that's relevant to each subset. But in this case, let's say I'm dealing with a couple of hundred comments in each bucket that actually have some kind of concrete recommendation in there, in addition to dealing with the subject matter of choice. So from that subset of data, that's what I hand to a large language model to get a summary of. in addition to, you'll see on this slide, providing ways to dig in for more feedback. So when my large language model comes back to me and starts talking to me about how rude the customers were, or rather how rude the staff were, and also maybe you should put a program in place to train your staff on the importance of proper customer interactions, which it does, one of those first negative recommendations in there. I can then, instead of like just referring to a block of text that my large language model points me to, like use traditional capabilities. They're so useful still. I can highlight some of that key terminology. I can drill down on rude staff, terminology like intimidating, unfriendly, and drill down into all the different statements across all the different reports that highlight those kind of issues. Let me actually go back to that slide, because I think it's like worth highlighting a few more things on here. So in this case particularly, like I was seeing unfriendly staff, rude staff, unprofessional. And then what was really cool here is we were also able to identify that like one of the airports in particular had an issue with the evening shift. It was like it was performing very well over most of the different segments. But we identified that one of the airports during the evening shift, its like star rating just dropped below the other ones. And that's where we could also use text analytics to start getting at some of that terminology in there. So backing up one step, I'm going up and down because I'm getting my exercise while I'm presenting to you. On the left-hand side, that's what was created by the large language model. It was using data that was generated from text analytics, and we used text analytics to help you verify it. So I could drill down on any of that terminology like mediocre, etc. This next slide is also showing you, using text analytics, some of the key terminology that went into what's happening at one of the airports in the evening shift that might be bad. And a big chunk of that was whenever anybody mentioned the word customs in there. So if people are mentioning customs in the context of the evening shift at this particular airport, I can then drill down and identify all the different statements where, as it turns out, they were just understaffed at that particular period. So having the airports understand like, hey, the understaffing at this particular segment of time is actually severely impacting the level of satisfaction at my airport might help them devote those very limited resources they have into a better place. How are we doing on time?
I was just about to give you a halfway mark.
Halfway mark?
2 minutes away from 10 minutes.
2 minutes away from 10 minutes. Cool. So I've been talking for 8 minutes, or?
Yeah, yes.
Oh, fantastic. So we got more time to talk. Okay. So we'll go back to, choose your own adventure. All right. Who wants to see more on food safety inspections? Okay, I see a hand. I see a couple hands. Regulations analysis. None? Okay, okay. How about R&D funding to sustainable development goals? Cool. I see a couple of hands. All right. You guys are just interested in whatever it is I'm going to throw at you. I'll take that too. I like this one because this one was like relatable to both banks and then like public sector as well, because we have like our own set of financial services. And at the end of this presentation, I'd love to chat with you a little bit more, either here in this context or at the booth, about like, as you see this and you can think about some of your own workflows, maybe that deal with public sector, what would you like to focus on? Like, I've been doing this for years, and I'd be happy to talk through like scenarios and use cases with you. So the idea here is SAS actually has its own data set that's related to risk for different banks. So we have like 40,000 events related to operational loss at financial institutions. And like the idea is, what can you do with this data to help different financial institutions be more, or rather like suffer less from like fraud or risk or financial like harm? So what we did here is actually specifically use capabilities around like entity extraction, generative AI, and summarization. This all falls under that natural language processing umbrella. Using those 40,000 events that SAS curates over the course of, geez, we've been curating this for over 30 years. There was a lot of structured data in here, but a lot of narrative data to process as well. And what we can do is look over like whole periods of time and identify like different banks that had been subject to credit fraud and mortgage fraud over time. So these were the activities that we identified. Here are the different counts of those banks where they've had like those number of experiences. And what I could have also done here is totaled up the loss, the operational loss, because in some cases it's in the billions for these different organizations. And then I could just focus on like one such institution, and I could look specifically at the different cross-cutting patterns related to fraud and assess what those are. And this is again another case where I looked across those events. I built a text model to flag just those statements that very specifically had to do with fraud related to some kind of financial loss, and then highlight some of the key terminology around that. So now when I stand up, this one's related specifically to Citibank, I could look at a very high level, everything that Citibank encountered over the course of time and where it experienced, let's say, the most fraudulent type issues. And some of that was internal fraud, credit fraud, mortgage fraud, identity theft. Now this is my own analysis, so don't take this all for gold, but you could probably research some of these and see similar things related on the internet. But then when the large language model summarizes, hey, this is what's been happening to Citibank over time from a subset of the data we pulled from these risk reports, summary created by, in this case, it was OpenAI. And down below, as I highlight, you can verify the summary with essentially the kind of widgets you get from a dashboard. I could flag certain like terminology here, like for instance, the large language model claims that credit fraud schemes, including the use of stolen identities, were used to open fraudulent accounts, make unauthorized purchases. Well, I'm seeing a lot of terminology down here related to lines of credit, financial documents, fraudulent financial documents, and identity theft. And I can drill down into those statements directly to verify what Citibank has been encountering, that it indeed has a lot of these patterns related to theft. These two talk specifically about essentially standing up fraudulent financial organizations and straw borrowers, opening lines of credit, and there were millions of dollars in fraud that impacted Citibank related to these kind of schemes over time. So knowing that, like that's where an organization like this can take this kind of information and make an action plan going forward to better assess, because they have their own internal data as well that's a lot richer than what you get publicly, and assess how to prevent fraud related to, let's say, identity theft, which is a huge issue going forward. Similarly, we did work looking at falsified documents, misrepresentation of property values, and that's another case where we can drill down into these fraudulent applications and flag the specific statements dealing with that. It's just another way where like you can take information from a large language model and verify that it's accurate using dashboards like this for drill down. This is some of the stuff we've been focusing in on for public sector. How are we doing on time? Okay. So 5 minutes, I would love to take some questions. If you have some ideas of some use cases that you would like to just talk about like before the group, or like some areas where maybe this has impacted your own business process, or basically just any case where you've dealt with, I have more unstructured data or reports or events or documents than I can possibly deal with. I can be really patient. Thank you.
I can't hear myself.
Oh, there you go.
Yeah. Have you looked at any data post disasters to look at what the impacts have been and cost associated with it and stuff like that?
Yes, I was working actually with and this was before COVID. I was working with one of the HHS organizations. It was ASPR actually, and what we were doing specifically with them was looking at when they have those stand-up clinics, who's coming in for what. But the deal is they only have so many doctors at those, so they can only make so many diagnoses. So let's say there were 30,000 people who came into one of those clinics, and we only have 5,000 diagnoses. Well, that doesn't give an entirely accurate picture of what people were coming in for because we've only classified 5,000 of them. But we built a text model essentially that would do auto-categorization of the other 25,000 based on the narrative description and how the first 5,000 were classified to better give a full and accurate picture of what was needed at these clinics. So one case we identified is people were coming to the clinics because they couldn't get access to oxygen. Like they have those oxygen tanks and stuff. And that's a great way to help like staff and provide resources to these organizations knowing like, oh, these many people came in for this kind of purpose. That was one of the key things I remember from that particular use case. Yeah, so does that answer your question? Thanks for asking a question. Anybody else? All right, well, you know where to find me. I'll be here and I'll be over at the public sector booth. And thanks so much for coming and attending.